All right, for this video, we're going to do a brief introduction of the very last section that'll be on the midterm. You can see we're moving on to 6.3. It's called linear combinations and elimination. This is the third method that we're going to use to find the point of intersection. And it's going to be more algebra based. I think this method a lot of students like, and it might be the easiest in a lot of cases. First thing you could do on your note sheet is just write down the definitions there for elimination and then write down the goal. So you can stop the video right now and just write down those definitions. Okay, after you wrote those down, I'm just going to explain it briefly. Elimination, basically what you want to do is we want to add or subtract. Most likely we're just going to add the equations, and when you add equations together, your whole goal is you want to eliminate one variable. You could eliminate x or you could eliminate y. Well, now the question is, how do you eliminate x or how do you eliminate y? Well, we're going to look at the goal. Here's the main thing. We want to line up like terms. So now I'm not going to be worried about always putting the equation in slope-intercept form. And then after you line up the like terms, this is what you want. You want the variables, at least the like variables, to be opposites. Here's an example. I'm going to write this up here. If I have x, the opposite of that is negative x. And the reason why is if I add these together, they cancel out. Here's another example. The x's don't always cancel out. Let's say I have 2y. The opposite of 2y is negative 2y. So when I add these, it eliminates and I cancel out. Okay? So now let's apply it to a linear system. But that's what we want to look for. I want to get either the x's or the y's. I want to get their coefficients to be opposites of each other. So then after I add them up, they cancel out and they go away, and then I'll only have one variable. All right, I'm just going to do 1, 2, and 3. So I'm just going to focus in here on number 1. All right, there, make it bigger. All right, okay. So if I look at 1, now you can see how I'm going to just put this there, kind of like an equal sign. I can see how I have my x's lined up, the y's lined up, and I also have the equals lined up. So here I have the x's, the y's are lined up, and more importantly, the equal signs are lined up, and the constants are lined up. So that's what you have to have in order to do linear combinations or elimination. Now the one thing that I look here, the y's, these are already opposites of each other. That's what I want. So that's my goal. Since they're opposites of each other, I'm going to put a big plus sign. I'm going to add these equations together. Now if I add this, x plus 4x is 5x. And then if I add 3y and negative 3y, that's 0. It goes away. I eliminate it. That's what I want. Then I'm going to put equals, and then when I add the 6 and the 4, 6 plus 4 is 10. So I didn't have to get anything in slope-intercept form. Just like that, I got rid of the x's. I have a simple one-step equation. Divide by 5, divide by 5, so x equals 2. Very, very quick. Now to get y, it's going to be the same thing that I did with substitution. I could take this x equals 2, and I could plug it into this x or this x, and then solve for the y. I think this first equation is going to be easier because the numbers are smaller. So I'm going to plug 2, and I'm going to plug it into that x. So it's going to be 2 plus, and then it's 3y, so it's 3y equals this 6 right there. So then we subtract 2. Subtract 2 from both sides. So we have 3y equals 6 minus 2, which is 4. Then divide by 3. I'm just going to put this up here. And you're going to have y equals 4/3. Okay? All right. So if you graph these two lines, they would intersect. The x value is 2. The y value is 4/3. So it was pretty quick. I think a lot quicker than substitution. All right, let's look at number 2. You know, maybe we'll just do number 2 on that, and then that'll be it. We'll start out with number 3 in class tomorrow. All right, with number 2, again, I want to ask myself, well, first of all, are the terms lined up? They are. I have x and x. I have y and y. The equal signs are lined up. The constants are lined up. So I'm ready to go. Now I ask myself, do I have opposites for variables? And I do right here. X and negative x, they're opposites. So I can go right away and add these equations, and this is going to cancel out. I'm going to eliminate the x's first. So I'm going to put the line here. I'm going to put a plus. So when I add x plus negative x is 0, I eliminate that. When I add my y's, don't forget the negative before. Negative 2y plus negative 3y is negative 5y. and then I'll put the equals, and then -4 plus -1 is -5. So just like that, I have a very easy one-step equation. Well, if you divide both sides by -5, the negatives are going to cancel, and you get y to equal 1. And then, just like substitution, once you get the value of one variable, I could take this y equals 1, I could plug it in here or in the first one. Let's see here, I'm going to plug it in the first one again. Either one you could plug it in, but I'm going to plug that 1 in right there. So when I do that, let's do this. I'm going to have x minus 2 times, figured out y was 1. So I'm going to have 2 times 1 equals -4. So then this 2 times 1 is 2. So I'm going to have x minus 2 equals -4. Then I add the 2 to both sides. So this -4 plus 2 is what? -2? And then I have both of my variables. X is -2 and y is 1. So the ordered pair for this is -2, 1. Alright, so we looked at the most basic kinds where the x's and the y's, they're already lined up and you do have opposites. Tomorrow we'll probably look at cases where they're not lined up, or when they are lined up, they're not opposites. So I give you a good intro to elimination or linear combinations.